we will continue our discussion on computer networks and internet protocol. So, today we will be discussing on in this lecture protocol stack or a overview of the protocol stack, OSI and TCP IP, these two protocol stack, though we will be primarily following the TCP IP, but just we will have a overview of the OSI. So, before going into this protocol stack, that overview of the protocol stacks, what we will try to look at that a quick we look at a quickly look at the history of this internet or internet working, how it evolved over years type of things, right. So, if you go to, there are two interesting site, one is in a YouTube and also in another site where you will get lot of history informations, but if we try to correlate from different sources, if we see that the history how this internet came into picture. So, it starts from 1836 when the telegraph fast telegraph message was sent, and it has been seen that Morse code, a series of dot and dashes which was used for communication, and somewhat we find analogy with our today's binary 0 and 1. Then somewhere between 58 and 1858 and 66. So, transatlantic, there is a effort of transatlantic cable, and if you see today also this huge submarine cables primarily forms the major backbone of the data communication part, and in then came telephone lines which revolutionized our way of connecting things. And if you see that our earlier network connections, these days also there are connections which piggyback on this, primarily use this telephone line as a physical layer. And then gradually somewhere in mid 1950s or 1950 around, so US formed that Advanced Research Project Agency or ARPA. So, this is one of the major step under Department of Defense which was there, and there was a parallel, if means I should not, that is not on the network front, but there at the around that time USSR launched Sputnik. So, some sort of a there are reports that there is some counter or some parallel efforts was there. Now, in 1962 this ARPA net was formed, which primarily aimed at finding a network which will allow some sort of a resilient and reliable connectivity during very extreme situations, right. So, that is the major thing, and we see that in around 60s, early 60s, the packet switching network developed. So, we will discuss about circuit switching and packet switching in our subsequent lectures. So, it was developed where data is split into small packets which may take different routes to the destination. So, it will follow different routes to the destination, but data is small packet, and that the union or the all these packets are primarily at the destination or intermediate things, intermediate devices or protocols will to continue. In 69, ARPA net commissioned by DOD for research, primarily evolved as a research network, where 4 major US university came into picture, like University of California at Los Angeles, like UCLA, that is Stanford Research Institute, and then UCSB and University of Utah. So, this is the major 4 things came into play, and what we see, it gets a open research motivation of the things. So long it is under the Department of Defense, it is more of a what we say secure type of things, but here it gets a more university flavor where the number of research efforts has came into play, right. And then what we see in 71, that first email program was transmitted. It seems that the first program was the first row of the alphabet in our typical quadtree keyboard, and with 15 nodes or with 23 hosts on ARPANET. Then in 73, global networking became some sort of a reality, connecting in England and Norway. So, it is some sort of across country or across continent. In 74, these packets become more mode of switching, that is evolution of transmission control protocol and other things came into play, right. And in 77, what we see that number of email hosts became, email is really reality, there were hosts were 100 plus hosts were communicating, and there was a steep increase after that on overall effort. 79 news groups were formed, 82 TCP IP protocol was proposed for ARPANET. Then there is a major development in 83 where name servers were developed, right, like it was becoming difficult to remember the IP numbers and etc. So, name server was developed. In 84, DNS came into play, number of hosts crosses 1000. By 87, it crossed 30,000. Then we see gradual increase. 89, primarily this is our omnipresent www or www concept was coined by team Berners-Lee. So, in 90, what we see in first search engine, what was proposed, number of hosts was 3 lakh plus, around 1000 news groups, and at the same time ARPANET was ceased to exist officially, or it went to a distributed development mode, and there is no practically that what we say existence of ARPANET was not there. In 91, developed user friendly user interface for internet, primarily Gopher, some of you might have heard about it, released by was released, and text based menu driven interface access of internet resources was possible through Gopher. Then 92 was a more multimedia came into much into play, and so called quote unquote surfing the net was term was coined. 93 onwards, truly this www revolution begins, number of hosts cross millions, and Mosaic web browser are launched, right. So, then onwards what we have seen as a phenomenon growth with different type of applications, different type of content and so on and so forth. And if we look at some of the things, like if we look at that is web explosion, say 84, 94 it was around 3.2, these are from different internet resources. So, I do not claim that all are pretty or authentic to the last bit of the numbers, but it shows that how things grows in a big way. In 95 it was 6.4 million, 97 19.5, to 2001 it is 110 million hosts or 30 million websites and so on and so forth, and this expansion continues, right. It is exponential or expansion. Also there are some other things like 94 Hotmail came into picture, W3C was founded in 1994, 95 Java source code was released, and what we see that there are other starts ICQ or ICQ type of application in 96 by Israel, and in 1998 Google was founded. So, these are some of the milestone which shows that not only that growth of the things, the overall interest of the human community at large towards this internet this internet working. So, we just try to come back where we started from. So, this is a brief after this very brief history that how things are there. What we see now, it is a huge volume of applications, right, or huge volume of applications on the net. Some of the applications, if you see, they are pretty sensitive on error. Some of the applications are pretty sensitive on time. Some needs more data to be handled, some needs more accuracy and type of things, and this application from anything and everything feasible for our from day to day life to scientific application and so on and so forth, right. Rather what we see for typically for last 1 decade or so with different services or internet based services being enabled, or whole scenario or information system design is moving towards a what we say service oriented architecture. This network became a major thing to be considered. With cloud, high performance computing coming into play, so this overall backbone network plays the important role. This any interruption of the network will make the not only make us difficult to communicate, but several industrial processes will come into a standstill. So, it becomes extremely important to have this network in place. So, as I was mentioning in our earlier lecture that we like to see that what are the basic protocols, what are the basic processes, methodology, algorithms at the behind this overall networking, right. So, that is one of our major goal of the things. Now, if we just again recap from our earlier talk, like we primarily have protocol stack, right. We discussed about this, we will again little bit relook on the whole thing. So, there is a physical layer, data link layer, network layer, transport layer, application layer, right. And it is not necessarily all devices should manifest all the layers, right, that also we have seen, right. So, in other sense, the application layer at the top is basically the applications what we are working with. So, the application layer is the output of this so called application layer is piggybacked or became a payload of the transport layer. The output of the transport layer or will become a payload for the network layer, and the subsequently payload for the data link, and then it is the physical layer, and the physical layer takes care about the physical communication between two nodes, right, between the two nodes, like. So, it can be somewhere wireless and different type of technologies coming into play. So, that is the basic bottom line of the things. And if we look at that different type of services, then the popular services, so to say, HTTP, FTP and SMTP are the very popular services at the application layer. Not only that, if you look at our these days several web services, these basically piggyback on this sort of services. So, it is above application layer, right. So, they use application layer, like HTTP protocol is being used to carry some say SOAP messages or type of things, right. Similarly, at the transport level we have TCP, UDP, RTP, some are connection oriented, connection less, real time protocols. Then at the network layer we have different protocols like IPv4, IPv6, MPLS, these are the very prominent protocols. Data link layer Ethernet is one of the major protocol, Wi-Fi, Bluetooth, UMTS and LTE are the other protocols which are there. And physical layer is basically the physical connectivity, and it goes on the communication system processes and methodologies and technologies. There are some of the protocols as we discussed, like DNS, domain name system, or SNMP for management protocol, or ARP and DHCP for some of the address resolution protocols. So, these are the protocols which are somewhat cross layer protocols, right. They exist between two layers. So, they basically interfaces between the two layers, right. So, we will discuss these things in details in the subsequent lectures or some subsequent talks. But this is our all encompassing things. So, we will be mostly hovering around the TCP, primarily looking out at these major protocols, and of course, opening up that what are the other protocols and other things, etc. Now, if as we are discussing about protocols, so what is the meaning of protocol, right? What do we mean by when it is protocol? It may be for networking or any other aspects also. We say that the protocol to be maintained, etc. So, protocol is a controlled sequence of messages that is exchanged between the two or more systems to accomplish a given task, right. So, when I say that I do a FTP communication, I do a SSH communication, I do a HTTP or a DNS system resolution DHCP. So, I do a controlled set of messages, right. So, that where between two party or multi party to accomplish a given task, right. So, some may be downloading some documents or some may be resolving some network configuration, IP address and so on and so forth. Protocol specification define this sequence together with the format or layout of the message that are exchanged, right. So, one is that protocol is a set of messages to be exchanged, and there is a protocol specification that how where the what message, what is the specification, how many, what is the size, what are the different fields of the message, those are precisely defined. So, you define this sequence, define this sequence together with a format or layout of the message that are exchanged. So, that the other party on receiving the message can basically decipher based on the specification of the message. Like I say, if I send a particular DHCP packet, the DHCP receiver can basically open the packet and it knows that these are the way it is sequenced. Similarly, for any other protocol. So, that makes this what we say interoperate between variety of things. Like if I say that I am following so and so protocol, then I am done with the things, that other things. So, I say I am following IEEE so and so protocol, and then the other end basically only understand the specification, no need of any no need of any understanding separately, knowing that what is the format, etc. That is that exactly tries to do. So, whole any this sort of distributed, loosely coupled and autonomous systems or autonomous systems and services, when they communicate, these protocols played a very important role. So, in this basically in this course we try to look whole thing in terms of different internetworking protocol, which makes it possible to communicate between any two devices over the network. Now, one of the very major effort was made to define the protocols in a bigger in a more specific way, that is the what we say OSI model layers of the networking. Unlike our TCP/IP things, where which is a 5-layer stack, in some cases they consider as a 4-layer stack, we will come to that, but nevertheless it is a 5-layer stack. OSI is typically a 7-layer stack, right. So, it has physical, data link, network, transport, session and presentation, additional things what we see here, and the application. In the TCP/IP also these things are there, but they are merged with the other layers, right. So, physical is primarily, as we are discussing, transmission of binary data on over a media, right. So, this is a thing. So, when if I get say a digital or binary data which is carried over the medium. Data link is a transfer of units of information, framing and error checking. So, this is the data link layer consideration, primarily one of the functions which it does. Network layer primarily involved for delivery of packets of information which includes routing, right. Rather, what we will see that network layer, it is what we say it is not a reliable layer. So, it is it delivers packet in a unreliable way, means that is reliability is not guaranteed, whereas transport is a provision of end-to-end reliable and unreliable delivery both, right. So, though transport layer sits over network layer, it has the protocols supports to for giving a provision for end-to-end reliable service, or in case of a unreliable services, right. Session establishes and maintains sessions. So, this is a session layer which establishes and maintains sessions. Presentation is data formatting and encryption, if any, so that it takes care. Application is network applications such as file transfer, terminal emulation and so on and so forth. So, all type of application at the application layer. So, these are the primarily these 7 OSI open system interconnection model for networking, which takes care of every part of the things. So, every network device will have all or some of these layers, right. It is not necessarily that all will be enabled, like as we are talking that a layer 2 switch is up to enabled up to layer 2, a layer 3 switch is up to layer 3 and so forth. So, that means it can have one or more layers or all the layers in some cases. So, that means it allows it to the things as we are discussing, just discussing that a packet of the application is piggyback is become a payload to the presentation, which in turns become a payload to the session and so forth, finally carried at the physical layer to the other end. So, TCP IP on the other end is one of the very prominent protocol, which is being started long back and being used or being followed in different type of network enabled devices. So, it is a suite of protocols that become the dominant standard for internet networking, right. TCP IP presents a set of public standards that specify how packets of information are exchanged between the computer of one or more networks, right. So, it is not only confined in the one network, it can be between any two system in between any two network. So, if we try to compare this TCP IP, so somewhere we try to match like this, like physical data link network etc., whereas transport of the TCP IP takes care a little bit of the part of the session and the transport, whereas the application takes care presentation and the application and maybe little bit of the session layer. So, this is it is not like that something is left out or something new is there, but TCP IP is somewhere in between. And if we look at that the different type of protocols which are supported by different layer of TCP IP are a variety of protocols. These are some of the what we say standard or values protocols. There can be other protocols so and so forth, like data link layer, that can be fiber optic, it can be UTP, coax, microwave, satellite, STP and different type of links. Whereas data link layer there can be different other things like Ethernet, which or IEEE 802.3 standard or X.25 token ring, frame relay and different sort of protocols. In networking with TCP IP, the networking is over IP. So, it can be IPv4 or these days IPv6, transport TCP, UDP, ICMP and this sort of protocol, whereas application has a big bunch of protocol, right. It can be variety of protocols. There are issues of which are intermediate protocols, where which are between the different cross layer protocols etc., but that is some view. So, of this TCP IP stack. Similarly, if we try to look at some other way of looking at it, like this is other way of, as I was mentioning, there some places it is considered as a 4 layer stack instead of data link and physical in the TCP IP considered as a single layer stack. So, as we are mentioning that user data at the top becomes a payload for this next layer, right, and with the application header etc., it becomes a application data which is a payload for the next layer, which becomes a payload for the, which in turn the whole thing become a payload for the next layer and so forth. Like at the physical layer, physical level, this whole data is transmitted through the underlying physical channel, right. So, we will try to see that different protocol structure and what it sizes, including its payload wherever it is applicable, right, in this particular lecture. So, why different type of things what we are looking at? Because in different books, different internet resources, you will say that different representations. So, I thought that I will try to get will put some of the things, so that we should not get much confused with the things. Now, let us see consider a typical local area network, right. What will be the typical component? There are clients, there are servers, right. So, client is in servers are serving for some application or something, like there is a FTP server, FTP client, HTTP server, or sometimes we say HTTP daemon and HTTP client. Like what we use from the browser at my end is the HTTP server. If I accessing iitkgpsc.in, so it is a HTTP server is there. From I am a HTTP client, my browser is a HTTP client. And if we look at the network devices, there are several devices: repeaters, hub, transceiver, NICs, bridge, switches, routers. These are the different type of devices we have to see, which are at different layers. Like repeaters and hubs are primarily at the layer 1, whereas NIC, bridges, layer 2 switches are layer 2, and routers and so forth. So, if I and there is a concept of local area network, wide area network, we like to see look at it. So, a WAN is a data communication networking covering a large geographic span. Unlike LANs, a WAN connection is generally rented from a service provider. So, when you go for a WAN connection, it is from the service provider. WANs connects various sites at different geographic locations, so that information can be exchanged. So, there is a concept of WAN and LAN. Primarily that way of handling will be different, but nevertheless the devices etc., or the way the protocol works remains same. Now, if we see that so it is a layer 1, layer 2, layer 3 and type of devices. So, let us see that so NIC, typically the network interface card, which what we are having in our all systems, laptops, PC etc., are basically having as a layer 2 device. So, it is having MAC address or sometimes called hardware address, which is with that interface card, right. So, it is a unique address, so called unique address, which is given by the from the OEM or the manufacturer, right. There you may argue there are way to spoof etc., that we are not going to those business, but we consider that MAC address is a unique address given by the hardware address given by the things. We will come to those things. So, if I have two computers with a NIC cards, the first LAN how to connect is connect to encoded by the cable. Only thing that should be a crossover cable, that means the transmitter or TX of one should go to the RX and RX of the other should go to the TX. So, it is a crossover cable or what sometimes what we say cross cables, right. So, if it is typically can connect 100 meters things at a that maximum things, it may be little less than that, and if I have to go more than that, I require a some repeater or which amplifies the signal, right. And if I want to connect more than two things, then I require a multi-port repeater or popularly we call as a hub. These are all layer 1 devices. So, it is only amplifying the signals and type of things, right. And if the business expands and I have cascade of things, right. So, one repeater, another hub, again hub and go on expanding. So, what will happen that the problem is that hubs share a bandwidth between all attached devices. Like typically if it is a say 10 Mbps hub with 8 ports, so effective bandwidth is 10 by 8, right. So, it is what we say that worst case scenario will come like that. So, hubs are layer 1 devices, cannot filter traffic. Most LANs use broadcast technology. So, every device sees everyone, and it's like if there is a communication is there. So, it is everywhere the things are there. So, there are lot of collisions and there are lot of things, though only one is sending to 2, only 2 should expand, but all will getting the collision things. So, the solution is whether we can have a smarter hub or bridge. So, bridge filter traffic based on the MAC address, that means as every NICs have a unique MAC address or every system has a unique MAC address. So, they filter traffic based on the MAC address. So, how it looks like? So, if I send a instead that bridges, then the traffic are localized, right. So, localized. So, it is the traffic will not cross these things, so that the other parts are bandwidth are not wasted. So, if it is if there is a multi-port bridge, we say that is a switch, or more precisely is a layer 2 switch. So, there can be layer 2 switch where it connects etcetera, it can have a connection to the cloud. In this case the cloud is internet cloud what we mean, and that is a we can have this sort of connectivity with the cloud, right. So, and then comes the router. If the two networks are different, routers filter traffic based on IP address. The IP address tells the router which LAN segment and segment can ping belong. That in other sense where you can have the thing. So, these two networks are different networks. So, one is machine 1 is one network, the machine 2 is in other network. This router finds the path from this to this. So, in other sense it is not only filters the collision, it not only divides the collision domain, it also divides the broadcast domains. So, that it is only allowed filter the traffic, those traffics to the other things. So, what we look at it, so there are devices at different level, typically routers are layer 3, these are layer 2 switches, there are layer 1 devices, and also each device works its layer, but all the things. The router has the property of data link and also physical. So, any higher layer has all the properties of the lower layer thing. So, if you have a router, it has all the other properties. So, that means it can basically do data link layer filtering, also can communicate and all those things, right. So, as that layer 3 device, but also uses MAC layer and so on and so forth, right. So, and typically when we will come to those things later on, it is a what we look at as a hierarchical design of network, where we have a that core at the things, then distribution, then the access, right. So, the core is very fast, then distribution is more the policy, and the access is the end mile type of solution. Let us have quickly few points and before we conclude. So, routers by default breaks up broadcast domain. Broadcast domain set of all devices on a network segment that hear all the broadcasts sent to the segment. Breaking up the network broadcast domain is important because when the host and the server sends network broadcast, every device on the must read and process that broadcast, right. It may reject or accept based on whether it is meant for that. When a router interface receives the broadcast, it discards the broadcast without forwarding to the network. Routers also breaks up collision domain, right. Switches are not used to create internetworking. So, that is for router, they are employed to add functionality to the internet LAN. So, switches breaks up collision domain, it switches frame from one part to the other part in a switch network, so to say, that is why the switch. So, again collision domain in Ethernet term used to describe a network scenario in which one particular device sends a packet to the network segment, forcing other device in the same segment to pay attention to it. At the same time, with different device there will be collision, loss of data and retransmission and loss of bandwidth. It typically found in a layer 1 or hub. So, each and every port on a switch is own collision domain and hub represent one collision domain and so forth. So, what we try to say that this different layer of the things has different level of functionalities, right. One is basically that different, like at the physical layer is more of the physical transmission of the things, whereas data link layer takes care of the filtering at the MAC layer level and also communicate between so that it is filtered and the collision domain are divided. Routers typically layer 3 device connects to devices on the network. More precisely, if we see that it helps me in internetworking, if we go to the transport, it connects two processes into machines in the internetwork. So, that is process to process communication is feasible by this transport, and the applications what we are interested in or what the end user is interested in, where the end user basically use these different applications like what we use in internetworking and type of things. And also we have seen that every layer processes and piggyback make its payload and from the things. So, let us conclude here. We will continue our discussion on the things as we mentioned that we will go on a top down approach. So, we will go from application to transport and so on and so forth. Okay. So, let us stop here. Thank you.